let's practice some question about solubility. So we have a compound. The compound is sodium phosphate. We add it to calcium nitrate, and it will give you product. So the question is going to be, tell me the product, write the product, next balance the reaction, and after balance the reaction, write the state of each compound. Tell me whether they are soluble or not. So in order to complete the reaction, what you need to do, just simply switch position of the cations. I'm talking about here, sodium and calcium. Just switch their position and everything will be fine. But keep it in your mind that each ion comes with different charge. So I will write here, I will say calcium, and pair it with the phosphate. Calcium has +2, phosphate is -3. So I need to have 3 from calcium to cancel charge of the phosphate. And I need to have 2 of them. Okay, you see. You put parentheses in front of it, and then you put the sodium in the front of nitrate. Sodium is a +1, nitrate is -1. So the simplest ratio between them is going to be 1 to 1. Okay, and then you write parentheses in front of it. Balance the reaction. Okay. We need to have 3 sodiums, 1 sodium there, about calcium, 3, 2. So let's put 3 here. Let me write a different color. I go 3 here. That means I need to have 2 for phosphate. So I will have 1 here. Okay, how about sodium? 2 multiply 3, it will be 6. So I need to have 6 here. Nitrate, you go 2 multiply 3, it will give you 6. 6 multiply 1, it will give you 6. So I got it balanced. Last thing that I need to write is going to be state of each compound, whether they are soluble or not. Okay, first compound, it will be soluble because of sodium. Sodium is a group 1. So sodium, it will make it soluble, you say aqueous. Next, calcium nitrate. Nitrate, it will make the calcium compound, calcium nitrate, soluble. So this is number 2. Rule number 2 says if you pair anything with nitrate, it will be soluble. You say aqueous. We have sodium nitrate. Sodium nitrate, because of sodium and nitrate, it will be soluble. So you say aqueous. Now let's check calcium phosphate. We're talking about number 5. Phosphate is not going to be soluble. Phosphate, it will be insoluble. So you say this one, it will be solid. And the reaction that you got until now, this one, it will be the overall molecular formula. We call it overall molecular formula. Okay, so you got the reaction balance. You wrote the state of each compound. Okay. Next step, I want you to break this one down to ions. Okay. So let's take entire of this. Okay. I got the reaction balance. I read the state of each compound. Now what I'm going to do, I will break each compound to ions form, and I will stay away from any compound that it has L, S, or G as a state of compound. So for those 3, I'm going to say keep them, or don't touch them. And the rest, just break them down to ions. That means any compound that has aqueous, break it down. So I'm going to break it down. I see 2 in the front of it. I will break it to sodium and phosphate ion. I get 2 multiply 3. It will give me 6 sodium ion plus 2 phosphate ion. This is the first compound. From the second compound, we will have 3 calcium ion plus 6 nitrate ion. And then you go product. We write it with different color. Product, I have calcium phosphate. It says solid. I will keep it as it is. So I'm not going to touch the calcium phosphate because it says solid. Then I will break down to next compound to here, 6 sodium ion plus 6 nitrate ions. And I will cross any compound, any ion that I have it cross out the the arrow. I see 6 sodiums. I will cross them by 6 sodiums. I see 6 nitrates. They will go. Forgive me, I actually crossed the wrong one. So we go 6 sodiums, 6 sodium by 6 sodium, and 6 nitrate by 6 nitrate. We are left with From the first one, we have 2 phosphate ion plus 3 calcium ion, and we get calcium phosphate. 2 phosphate, see 2 phosphate on the right side, 3 calcium on the right side. So the reaction is balanced. We call this the last formula, the last equation, we call it net ionic equation. So net ionic equation. So I got the overall molecular formula. I showed you how to write the state of each compound, how to get the product. The top one, I'm talking about this. This is the overall molecular formula. I broke it down to ions, and I said stay away from any compound that has L, S, or G. Okay. Keep them as they are. The rest, break them to ions. And I did it. I crossed the common stuff, cross out the arrow, and I wrote whatever left. And this is my net ionic equation. Another example. Go with this. You have lead nitrate. You add it to potassium chloride. Complete the reaction. Sorry, this one I should say here. Complete the reaction, balance it, and write the net ionic equation for it. So I told you, just simply switch position of the metals or the cations. You switch position of lead with potassium. Lead is 2 plus, nitrate is -1, potassium +1, chloride is -1. So you go with this. You go K, NO3. K is +1, nitrate is -1, 1 to 1. And then you say, you write the state of compound plus lead, you pair it with the chloride. Lead comes with +2, so you need to have 2 from chloride to cancel the charge. Now write the state for each compound. First one, because of the nitrate, it will be soluble, so you say aqueous. Second compound, because of chloride and potassium, it will be soluble. Product, again, because of potassium and nitrate, it will be soluble. Last one, it will be solid. Okay, balance the reaction. I have 1 lead, so I go 1 lead, 1 lead. Now that I put 1 in front of lead chloride, I will say 1 multiply 2 chloride, it will give me 2 chloride. That means I need to have 2 here. So I put 2 there. That one, it will make the potassium equal to 2. And also nitrate, we have it equal to 1 multiply 2 nitrate. It will give you 2 nitrate. So you need to have 2 there. And put 2 here, and it will fix it. So I'm going to put 2. The reaction will be balanced. Okay, let's break it down to ions for. First one, I will break it to lead ion plus 2 nitrate ion. Next, I go 2 potassium ion plus 2 chloride ion. Now I will get the product. Product, I see 2 potassium ion plus 2 nitrate ion. And then we get 1 mole from lead chloride, and it's solid. Okay, cross common stuff. I go 2 nitrates by 2 nitrates, 2 potassium by 2 potassium, and then we get this. We get lead ion plus 2 chloride ion, give us 1 mole from lead chloride in a solid state. This is going to be the net ionic equation. one more example, and it's going to be this: iron chloride plus silver nitrate. You will get silver chloride plus iron nitrate. Okay. Complete this reaction. Write the state of each compound, balance it. So you go. First ones will be aqueous because of the chloride. Iron is not heavy metal. Silver nitrate because of the nitrate, it will be soluble. Okay. Iron nitrate because of the nitrate, it will be soluble. A heavy metal like silver met chloride, so it will give you solid. You say S. Okay. Balance it. I see 3 chloride on the left, 1 on the right, so I'm going to put 3 here, and I put 1 in front of iron chloride. That means I have 1 iron, so I put 1 here. How about silver? I need to put 3 there to fix it, so it will be 3. 3 multiply 1 nitrate, 3, and on the right side we have 1 nitrate. 1 multiply 3, sorry, 1 multiply 3, it will be 3 nitrate, and it's going to be equal to number of nitrates on the left side. So reaction is balanced. That's a good news. Break it down to ions. You get 1 iron chloride ion plus 3 chloride ions from the first compound. Then you get 3 from silver ion plus 3 nitrates ions from the second compound. Then you get product. It says 3 moles of silver chloride solid. You keep it as it is. You don't touch the solid because it's already out of the solution phase. It's sitting at the bottom of the flask, so it's not inside the solution to break it down to ions. Then we write last one as iron plus 3 nitrates. Plus common stuff. I see 1 iron by 1 iron, 3 nitrates by 3 nitrates. We are left with 3 chloride ion plus 3 silver ion. We get 3 silver chloride. Technically, this is the net ionic equation, but we don't need to have 3 for each compound. Get rid of the 3, make it simple. You say 1 chloride plus 1 silver ion will give me 1 silver chloride. This is going to be the net ionic equation. I think we did enough example about solubility, net ionic equation. Okay. Let's do some example about how to use molarity to predict how much from a compound we need to add to crush the entire one, for example, heavy metal, or how much acid we need to add to a base to neutralize that base before we dump it inside our, say, sink. We want to know that we're not ruining that sink. Here's one example. It says we have potassium chloride. We add it to lead nitrate. We get lead chloride, solid, so it will crash, it will precipitate, and then we get also 2 moles from potassium nitrate. Tell me how much from potassium chloride I need to add to the lead nitrate to transfer the lead ion to lead chloride. So I want to clean the water sample, get rid of the lead from it, or simply somebody brought me water sample and asked me, can you figure what's the concentration of the lead inside that water sample? Tell me how much contamination of lead I have in it. So what I'm going to do, since I'm going to discard, I can take the reaction here, balance reaction. I'll write this one for myself. Okay. So the first step that you need to do to handle this type of questions, you write a balance reaction. Next, you say molarity, volume. It doesn't matter really which one. So let's say you go with volume And then you go molarity. Volume must be mole liter, molarity mole over liter. Okay. Volume of KCl, I don't have it. I'm looking for volume of KCl. So this one we don't have it. For lead nitrate, volume we have it equal to, says 0.150 liter. How about the concentrations? Concentration of potassium chloride is 0.150 mole over liter or molar, and the lead nitrate is 0.175 mole over liter. You start with a compound that you have volume and concentration for it, and that's going to be the lead nitrate. So you go after lead nitrate first. You have two ways to get the final answer. You can do it with dimension analysis and do it in one step, or go stepwise and get the final answer. Let's do it through multi-steps, and we go with this first. Here we go. Tell me what's the number of mole for lead nitrate. So I'm going to go with this. Step 1, number of mole, the molarity is equal to number of mole over volume. If I want to know number of mole of lead nitrate, is going to be equal to volume of lead nitrate multiply molarity. So we go number of mole of lead nitrate is going to be equal to volume is 0.150 liter. You multiply it by the molarity, 0.175 mole over liter. You cross liter by liter. And this one will give you number of mole equal to 0.026. And then one more here, and it will be mole of lead nitrate. So I got number of mole of lead nitrate. Second step, you look to the balance reaction. The balance reaction, it says 1 mole from lead nitrate. 1 mole from lead nitrate will react with 2 moles of KCl. So number of mole of KCl, it will be twice of the lead nitrate. So it's fair to say number of mole for KCl is 2 times of number of mole for lead nitrate. Or you can use dimension analysis and find number of mole for KCl. So I say 2 multiply 0.0263 mole, and that's going to give me 0.0525 mole of KCl. I said you can use dimension analysis, and you can say, or how many mole of KCl? I go with 0.0263 moles of lead nitrate to 1 mole of lead nitrate reacts with 2 moles of KCl, and you stop there. You cross mole of lead nitrate by mole of lead nitrate, and it will give you 0.0525 mole of KCl. So I got number of mole of KCl. Okay. Last step, or step 3, go with this. Molarity of KCl equal to number of mole of KCl divided by volume of KCl. We're looking for the volume. Volume will be number of mole divided by molarity. So you go number of mole, we just got it, is 0.0525 mole of KCl divided by molarity of KCl is given, and it's 0.150 mole over liter. You cross mole by mole, and that one it will give you the final answer equal to, I got it, 0.350 liter of KCl, which is equal to 350 milliliter of KCl. Okay, I put the dot to show that I have 3 sig fig. If you don't put the dot, then 0 is not significant, and you will have only 3 and 5 as significant figures. The final answer will be 2 sig fig. Okay. This is one way to go after the question. The second method that you can use will be the dimensional analysis, and you can do it in one step actually. You can write it this way. How many liter of KCl? This is the part that the question asking for it. You start with a compound that you have volume and molarity for it. That's going to be volume of the volume of lead nitrate. Volume of lead nitrate, let me check. Volume of lead nitrate is 0.150, so you go 0.150 liter of lead nitrate and multiply it by the molarity. The way you will read the molarity, 1 liter of lead nitrate has 0.175 mole of lead nitrate. You cross liter by liter, that's going to give you number of mole for lead nitrate. which is similar to step 1. Then you transfer mole of lead nitrate. So you say mole of lead nitrate. 1 mole of lead nitrate reacts with 2 moles of KCl. So use the mole ratio, and that's going to give you number of mole of KCl. Now that you have number of mole of KCl, if you divide it by the molarity, it will give you the volume, which is step 3. Okay, step 3, we divide the number of mole by molarity. I got number of mole of KCl. I need to divide it by divide it by the molarity. Let's cancel mole of lead nitrate by mole of lead nitrate. We're left with mole of KCl. So I go look at the molarity of KCl. We go 0.150 mole of KCl. We can find it in 1 liter. 1 liter of KCl. We cross mole of KCl by mole of KCl, and that one will give you the final answer in liter. It's going to be 0.350 liter of KCl. So this is step 3, and it will give you volume of KCl in liter. So you can do it through this method to get the final answer, and it's completely your call.